Welcome everybody to today's research seminar. This is part of two seminar series. One is the more or less semi-monthly series hosted by the Michigan Program in Survey and Data Science at the University of Michigan and the Joint Program in Survey Methodology at the University of Maryland. And the other seminar series is the Inclusive Research Matters series hosted by the Diversity, Equity, and Inclusion Working Group on Educational Programs at the Institute for Social Research at the University of Michigan. The Inclusive Research Seminar Series is intended to focus our attention on the connection between diversity, equity, and inclusion and doing the best social science. So the idea is that DE&I has real implications for research. For example, if certain groups are systematically mismeasured, that is less accurately than other groups, then they're not fully included in the research enterprise. And the results can lead to entirely unhelpful, even counterproductive policies or interventions. So developing methods that assure uniformly accurate measurement and estimates for all groups has to be a priority. Our speaker today is Dr. Joseph Cimpian, whose talk concerns the systematic mismeasurement of risk in one subgroup, sexual minority youth. And so it's very much about inclusive research. Joe's biosketch appears with the announcement for today's talk, so I won't read through it, but I strongly encourage you to read it online. In the interest of brevity, I'll just tell you that Joe is an associate professor of economics and education policy at New York University. His research focuses on the use and development of novel and rigorous methods to study equity and policy, particularly concerning language minorities, gender, and sexual minorities. His talk today is entitled How Invalid and Mischievous Survey Response Bias How invalid and mischievous survey responses bias estimates of LGBTQ heterosexual youth risk disparities. Joe, we're so grateful you've agreed to share some of your research with us today. The floor is yours.
Great. Thank you so much, Brett. Thanks for this nice introduction and also for inviting me to speak as part of the series, or these two series, I guess. Yeah, so I'll just jump into it, and I'll give you a little bit of background about this research. So this research started a little over a decade ago. Actually, it was probably around 2010 or so when I was at the University of Illinois at Urbana-Champaign, and one of my colleagues there, Dorothy Espelage, just rearranging some things on my screen. One of my colleagues there, Dorothy Espelage, who is now no longer at U of I, as I'm no longer at U of I. She studies bullying and socio-emotional learning and supports. And one time we got together and I said, do you have any data on LGBTQ status? And she said, oh yes, I have tons of data, because I was trying to identify data to study disparities between LGBTQ and LGBTQ and non-heterosexual, non-transgender youth before, but I couldn't get access to data. So she had data, and this was at the time that there was a lot of focus, a lot of media attention on suicidality and suicide risk of LGBTQ youth. And it was the time that It Gets Better started, and there was a lot of public interest around this too. So I thought, well, as a researcher, and what can I contribute to this discussion? And so I wanted to bring my skill set of quantitative analysis to study this. So we got the data and we did some analyses and we submitted the paper for review, as one does in academia. And a reviewer said, well, how do you know that the data are valid that we were working with? And I didn't know if the data were valid. They were self-administered questionnaires. They were self-reported. We didn't really have any way of verifying it, but it got me thinking, is there something more that we can do to think about the validity of the data and how much of an issue this should be when studying sensitive topics such as sexuality and gender identity? So that's a little bit of the background of how this started over a decade ago now. And the initial focus wasn't really on mischievous responders or invalid survey data, but in the process of doing the research, that became kind of the part of that kind of took over this line of research for me. Okay, so I'm going to start out with, oops, apparently I'm on the wrong thing. Okay, there we go. So I'm going to start out showing you some results. These will not be the main takeaway results, but I want to show you these results to at least get you thinking about it, what we're going to be discussing today. So I'm going to be using data from the Youth Risk Behavior Survey, the YRBS. Hopefully you can see my cursor on the screen here. And these are data collected every 2 years by the CDC. So these are data from the 2017 version of the Youth Risk Behavior Survey. And we're looking at many different risk disparities between LGBTQ, which is lesbian, gay, bisexual, or questioning in this data set, and heterosexual identified youth. We're dividing the analyses into males and into females. We can see how many respondents there are who say that they're male and say that they're female, and how many within each group say that they're LGBTQ. Here I'm showing you what I'm calling unadjusted relative risk estimates. And there are a bunch of different outcomes over here that we're looking at. So these numbers, they don't really matter. They're just the survey item that the CDC is reporting data to us but these are the outcomes that we're looking at. And we have a range of different outcomes, starting with some drug use outcomes to some bullying outcomes and suicidality related outcomes. What we can see though, is that overall, we see that LGBTQ, so this is not going to be focusing on transgender. So this isn't going to be focusing, at least this part, on gender identity, but rather on sexuality. What we see is LGBTQ reported youth are at elevated risk for this wide range of outcomes relative to their heterosexual peers. For instance, they're reporting that they're using intravenous drugs 4 times as often as heterosexual identified youth among the males, and then among the females, we see that that's even higher at 7 times as often. Same with steroid use, that's elevated. All these outcomes are elevated, including all the way down to feeling sad and hopeless, considering suicide, being bullied at school. Everything is statistically significant, with this one exception over here of skipping school for safety among females. But this is what we would be working with the data that are released from the CDC in the Youth Risk Behavior Survey of 2017. Okay, so the focus of this talk, however, is how do we know if the data are valid? And we'll never really know if the data are valid, but this is at least asking the question, are the data valid? And then thinking about what processes we could go through to try to determine if we're working with a robust set of findings or not. So I'm going to start out with some research that is not my research. It's actually from Shaito Fan and his colleagues. It was published in the journal Field Methods back in 2006. It's looking at disparities between adopted and non-adopted youth, and it's using data from the Ad Health survey, which started surveying kids in the mid-90s in school, and then it followed them, giving them in successive waves surveys in their home, asking their parents. It became a much more inclusive kind of way of many different modes of survey collection. But so initially the researchers were interested in disparities between adopted and non-adopted youth. So the way, and I have over here, triangulation method of identifying who I'm gonna say are invalid survey responses. So the students were given a self-administered questionnaire, or SAQ, and this was given to them in school. And out of the students who filled out this self-administered questionnaire, which was about 15,000, 464 of them reported that they were adopted on the SAQ. That was the first wave of data collection. Shortly after that, those data were collected, the Ad Health data collectors went to the homes of the youth, and they asked their parents, and they also asked the kids too. And so they had follow-up verification from the kids. But they asked the parents, is child's name Billy, your biological child, and does at least one biological parent live with Billy? So what they found was that about 19% of the kids who said that they were adopted on the self-administered questionnaire, it was later determined that they misreported their adoption status because their parents later said, no, that's our biological child, and at least one biological parent lives with a child, and the kid also said, no, these are my biological parents. So how does this affect the outcomes, right? Because what we're interested in are things here, like these are the outcomes we're interested in. And similarly, there were a wide range of outcomes that these researchers were interested in as well. So turning to the outcomes, we have a column here that shows these are all standardized differences, so you can kind of interpret them as Cohen's D's between true adoptees and non-adoptees. And then over in this column, we have the Cohen's D difference between false adoptees and non-adoptees. And so what we see going all the way down the column at the bottom, here it says the mean of the absolute effect size. On average, there's a negligible difference between true adoptees and non-adoptees. However, there's on average a little bit more than a 1 standard deviation difference between false adoptees and non-adoptees. And if we look at individual outcomes, we see that really there's no difference between true adoptees and non-adoptees in terms of positive feelings towards school, skipping school, but the kids who falsely reported that they were adopted are giving responses to whether or not they skipped school that are 2 standard deviations higher than non-adoptees, and similarly 2 standard deviations higher than true adoptees. And what this is doing is this roughly 20% of the kids who are of the adopted, in quotes, kids are giving such inflated estimates for the disparities that it ends up biasing the estimates for the true adoptees. So this resulted in the researchers, they had a paper published in Child Development, and then they ended up issuing a correction to that paper in Child Development, saying that a lot of the results they found were sensitive to the inclusion of the kids that they could verify were or were not, in fact, adopted. So I'm showing you here disparities between adopted and non-adopted kids, but I could also show you they looked at disparities between students who reported that they were foreign born and those who reported that they were born in the United States. Similarly, what they found was there were these mischievous responders, or jokesters as they called them, in the data that were falsely reporting that they were a member of a group. And in addition to falsely reporting that they were a member of the group, they were giving responses to these outcomes that were much higher than what we were seeing for the true adoptees. Similarly, those disparities were happening again for saying that they were disabled. It goes on and on. So you might think, well, I'm not sure if I want to use the ad health data. That's not really the takeaway that I want you to have here. I think the ad health is kind of cool because they do have this method of allowing for triangulation for at least some of the disparities that one might be interested in. However, the problem is not solely an ad health problem. With the bigger problem really is that there are these mischievous responders or jokesters who are falsely reporting that they are a member of a group that they think it might be funny to say that they are a member of, such as saying that they're adopted when they're not, or saying that they're born outside of the United States when they're not, or saying that they're disabled when they're not, or what we will ultimately get to, saying that they are LGBTQ when they're not, or saying that they're transgender when they're not. And then take that small sliver of kids who are not in that group, saying that they're a member of that group, and then giving exaggerated responses to the outcomes that we do care about those disparities for. So this isn't really solely an ad health concern. The bigger problem is that most studies don't have a way for us to clearly assess the extent of the concern, right? It's a sensitive topic to ask a kid, do you identify as gay or lesbian or bisexual, or questioning? And I mean, of course, adopted status can be a sensitive topic too, so can nativity status. A lot of these topics actually are sensitive, but maybe to varying degrees, somebody might argue. But it would be unacceptable to ask a kid if they identified as gay, and then to go to the parent and say, does your child identify as gay? And then use that as a way of triangulating the validity of the student's response. So, and oftentimes what we do when we're trying to collect data on sensitive topics, we give self-administered questionnaires that are anonymized. So it doesn't allow for a triangulation method. Okay, so that's kind of a bit of the background. And the type of students that I try to have us keep in mind are, or the type of responder, I work with data from students, so I oftentimes say students, but the type of student that I oftentimes have in mind is this mischievous responder, this little kid here with little devil horns, I guess. So there's two things that we keep in mind with the student. One thing is the truth. We'll never see the truth. We'll see only what he reported. And what happens with a mischievous responder is what he reports is what he finds funny to report. So the truth in this case is that the student is not adopted, that he identifies as heterosexual, and that he identifies as cisgender. However, what he reports on this survey in this prototypical mischievous responder example is he would report that he's adopted when he's not. He would report that he's gay when he's heterosexual. He would report that he's transgender when he's cisgender. Okay, so there's the identification of a minority group or a minoritized population that is happening first. And then beyond that, we're interested in disparities in particular outcomes. So is he suicidal? No, he's not suicidal, but he reports that he's suicidal. Now, the problem is, if we look at what he's reported, then what he's doing is he is a cisgender, heterosexual, non-adopted youth who is not suicidal, but is inflating the estimates of suicidality among adopted, gay, and transgender youth in this kind of response. Does he skip school? Yes, he does skip school. He reports that he skipped school. He's being truthful in this instance, right? So you might think, well, that's a good thing. But the thing is, because he has misidentified his group affiliations, what he's doing is he's inflating the estimates for skipping school among these other populations, not the populations that we would, that he truthfully should be associated with. So we could just, throw up our hands in the air and say, well, I don't know what to do because now I have these self-reported data. I never know what the truth is, right? I only see what somebody reports. And in this mischievous responder context, what he is reporting is what he kind of sees as funny or extreme kinds of responses. But we could say, when we work with a lot of these large data sets, there are the group identifications that we need for saying, well, this person is a member of this particular group that I'm interested in, or this other group that would be the comparison group, like, gay or heterosexual or cisgender, transgender. And then there are the outcomes that we're interested in. And then a lot of times there's a lot of other items that are on the survey that aren't necessarily the things that we're interested in, because we don't expect there to be differences between groups on those kinds of outcomes. And that's not in the focus of researchers for these kinds of comparisons. However, they may have useful information for helping us identify who might be a mischievous responder or not. So the key here is, what we want to do is we want to see if there are other items that should ostensibly be unrelated to the groups that we want to compare, but that might have similar features in their items, such as funny kinds of extreme options that might similarly draw a mischievous responder or an invalid responder to choose, that would allow us to identify who these people are, remove them, and then see how sensitive the estimates are. So that's the process we're going to go through. So what Dorothy and I did for an earlier paper, and then what I did for another paper also earlier, was we identified some items on the survey. So for instance, here, additionally on the survey, they ask items about, so this is not the youth risk behavior survey. This is, in this case, when we were doing this study, this was using the Dane County Youth Assessment. So this is Dane County, where in Wisconsin, it's where Madison, Wisconsin is. So some of the items that they had on the survey where they asked you, again, these are kids who are in high school. They were asking them, how many children do you have of your own? Not how many kids are there in the family, but how many do you have of your own? So we have to ask ourselves, do we think that that gay kids or transgender kids should have 2 or more children more often than heterosexual or cisgender kids, right? Do we think that they should be blind more often? Do we think they should be deaf more often? Do we think they should be in a gang more often? So these kinds of items are the kinds of things that might serve as a screener. And what we would think about here are, what is the truth for this particular kid? Is it true that he has 2 or more children, that he's blind, that he's deaf, that he's in a gang, that he's very short or very tall, that he has not been to the doctor in 5 more years? The truth for this kid is no to all of these questions. But what he ends up reporting is yes to all these questions, because he is the prototypical mischievous responder, where he's choosing the most extreme kinds of responses that he finds amusing. So to give an example of how this played out in this earlier study, if we're comparing cisgender and transgender, and I put cisgender and transgender in quotes because this is what the students are reporting as they're completing these self-administered questionnaires that are anonymous in school. We don't really know if they are cisgender or transgender. It's all just self-reported. I'm showing you the item and the low frequency response for, I'm just calling out item number 4 here, which is, are you blind or have a vision impairment? The low frequency response is yes. 3% of the kids who reported being cisgender say that they are blind or have a vision impairment, but nearly 1/3 of the kids who reported they were trans said that they are blind or have a vision impairment. Now, these are things that we don't expect to differ between cisgender and transgender kids, yet what we're seeing is there is a much higher response to the low frequency response option among the kids who report that they are trans. And this is consistent across all 10 of these items that we included in this screener. Now, we could look over here for now comparing heterosexual and LGBTQ, again, in quotes for both of them because we don't really know. And we see a similar kind of pattern where there's an elevated affirmative response to the low frequency response option. Oops, I clicked too fast. For the LGBTQ reported youth relative to the heterosexual reported youth. The disparity you'll see, like here it's about 3% and 14%, and here it's about 3% and 31%. So it's smaller here when we're looking at the LGBTQ and heterosexual disparities, but you'll also see that the LGBTQ sample size is larger than the trans sample size. So this is a common thing that we see with these mischievous and invalid responses, that there is a subset of students who will give a mischievous pattern of responses to a wide range of items, because that's what they do. And if the subpopulation that they are claiming to be a member of is a smaller subpopulation, then the mischievous responders are going to have a greater potential to bias the estimates of that subpopulation. So for trans kids, the trans population is smaller than the LGBTQ population in the survey. So the kids who will be mischievous responders or have the characteristics of mischievous responders throughout the survey are going to be more, they're going to have a greater effect among the smaller population of trans kids than among the slightly larger population of LGBTQ kids, which helps to explain what's going on here, why these are not as large of a difference. So the method that I proposed earlier was it was actually very simple. I said, well, why don't we just count up the number of low frequency responses? So there were 10 items on the screener. that we used. And that screener was, again, it was items that already existed in the survey. And we were just saying, we don't think that there should be differences between LGBTQ and heterosexual kids or transgender and cisgender kids on these items. We also did a comparison of disabled and non-disabled. Of course, we removed any item that could be related to a disability such as blind or deaf or height or weight. But you can go through a process like that and can say what should differ between these groups or could ostensibly differ and what shouldn't. And then the things that shouldn't differ are the ones that should make for a good screener set. So what we did is we counted up the number of low frequency response options, and what you see is how many kids are giving 10 low frequency, like affirmative low frequency responses to all 10 items. Well, it's only 5 of the kids who reported being cisgender, and there were over 11,000 kids who reported being cisgender. So that turns out to be 0.04%. So very close to zero here. However, there were 17 kids out of 204 who said that they were transgender who gave affirmative responses to all 10 low frequency responses. Now, those responses were all very low frequency themselves. And if you actually multiply the probabilities of all these things together, you get a vanishingly small number that is extremely close to zero. So it's really unlikely that, by chance, we should have over 8% of a subpopulation giving affirmative responses to all 10. So what I propose we do is that we simply just remove the kids who gave all 10 responses and estimate the disparities. We remove those who gave 9 responses and estimate the disparities, and go through successively removing the next set of low frequency responses by counts. So if we do that, and if we look at how a disparity changes, say for extreme suicidal ideation, which on this survey is reporting that you think about suicide almost all of the time. Now, in this survey, there were gradations of reporting how often you think about suicide, but saying that you think about suicide almost all of the time was the most extreme response, which is where we expect the mischievous responders to also be going to in terms of the outcomes that we're interested in. Okay, so the disparities here between the transgender and cisgender youth are shown here in standard deviation units. And this first estimate, where we see almost a 2 standard deviation difference, is if you use the full sample. So if you didn't do any sort of screening of the data, then you would have estimated that there is this is a 95% confidence interval. So you would have said that there is a statistically significant difference between transgender and cisgender youth of about 2 standard deviations, where the transgender youth are saying that they are thinking about suicide almost all the time at a rate of 2 standard deviations higher than cisgender youth are. Now, if we remove the kids who provided 6 or more low frequency responses on that screener, then we end up with an estimate that is greatly diminished. It's now about 1/4 of a standard deviation, and you could tell from the confidence interval that it's no longer statistically significant. Now, I should also mention that if you were to remove the students who provided 6 or more low frequency responses, then you'd be removing less than 1% of the data. So it's not a ton of students who are necessarily giving extreme responses and biasing the estimates. It can be a small sliver of the students, but the problem is they are students likely from the majority group, in this case, the cisgender group. A small sliver of them are claiming to be members of the minority group, the transgender group. And because the transgender group is such a small group, taking a small sliver of this very large population and moving them over to the transgender group is going to greatly distort the estimates. So we're seeing that happen here. And if you were to remove youth who gave 3 or more low frequency responses, and by this point, you've only removed about 2% of the data, the estimate now becomes 0 and is not statistically significant. Now, I don't want to give the impression that there couldn't be suicide differences between transgender and cisgender youth. This is with one survey, given at one time. Are the methods for identifying who the mischievous responders are, or the low frequency response option prevalent responders. There are assumptions to all of these things, right? And the other thing that I want to point out is that this outcome is extreme suicidal ideation. So thinking about suicide almost all of the time. Okay, so there could be disparities where they are thinking about suicide more often, but not necessarily almost all of the time that would persist. Okay, so all of this was from an earlier paper. There's a lot of stuff on this slide, so I'm just going to walk through a couple points. So yes, well, my name was different. I changed my name a few too many times, I think, from Robinson to Robinson Cimpian to Cimpian. So, but you can see them all here. But so when Dorothy and I published, this was the first time that we ended up putting a screener as part of the survey. And then every time we submit a paper, some reviewer would say, oh, this is really cool, the screener, why don't you write a paper on the screener? And then I ultimately did write a paper on the screener in 2014. And then since then, my colleagues and I have been changing the way that we identify who the mischievous responders are, or invalid survey responses more generally, so that we can try to more efficiently home in on who the youth are, and then see what the effects are as we either extract them from the data or most recently decrease their weight and do a propensity score reweighting kind of approach. So I'll talk about that more. What I want to talk about, and then at the very bottom, you'll see that increasingly we've been using registered reports, so we could pre-specify the hypotheses and the methods and say, this is what we're going to do. This is why this work is important. We don't have the data yet. When we get the data, this is what we're going to do. This is no longer an R&R, it's now an in principle accept, and that's what I'll be talking about. Okay, but another thing that I wanted to point out here is the methods have become more complex. They've moved from a count-based method to using some machine learning algorithms known as a boosted regression. A couple of different ways of using boosted regression, but what I want to point out is there is a human component to all of this, where one has to identify what the screener items are that they're going to identify as, there really shouldn't be a difference between the groups that we want to compare on these items, or there should be, and because there should be, we don't want to use this as a potential screener item. However, there are additional human components to this count-based approach, which is, well, you need to say which response option is the funny response option. You also need to specify what kind of combinations you expect there to be. Do you just want to treat them all additively, or do you think that there are some interactions that you want to put into your model to identify the likely invalid responses? So what we've moved to in this most recent approach is, yes, there still is a human component where you have to identify what are the screener items. Because, for instance, what we're working with when we're looking at disparities between, well, let me just also say that there's going to be these data-driven, more flexible kind of computer algorithm-driven components to it. That's great in some sense. The part that is important that there's a human involved with, though, is you wouldn't want to just let the algorithm run wild and say, okay, find differences between LGBTQ and non-LGBTQ kids, because if you did let it run wild and do that, then it would say, well, I can predict sexual identity very well. I can predict it on the basis of sexual attraction or sexual behavior, right? Or you could say, well, if you are a guy who has had sex with other guys, then guess what? You're more likely to report being that you are, that you identify as gay or bisexual, and in either sense, a sexual minority for the purposes of this study. And that's not something that would be a valid screener, right? That's not something that would validly predict differences between. Well, actually, what I'm saying is it does actually predict real differences between kids because they those two items do match up with each other. The things that we shouldn't expect there to be differences on are things like how often do gay kids eat carrots relative to how often straight kids eat carrots, or how often do they go to the dentist, or do they vary in terms of height. So those are the kinds of things that we as humans must identify. These are the items that the computer can look for patterns on. And then the way that it looks for patterns is more flexible and potentially more efficient. Okay, so what the current study that we're doing is we're going to use the 2019 Youth Risk Behavior Survey. What I showed you at the very beginning was using the 2017 Youth Risk Behavior Survey. And as you'll see down here, we used the 2017 YRBS as a pilot and like a proof of concept, and to test out all the code and make sure that things were working. There weren't any errors in that or things that we hadn't thought about in advance, so that then we could say, this is what we're going to do. Let's just get a whole new set of data and then see what happens there. So that's what we're going to do with the 2019 YRBS. And what we're going to do is we are combining a machine learning approach, which is boosted regression, with propensity score reweighting. So I'll tell you how the propensity score reweighting comes into that. And what we want to do is we want to minimize the likelihood of potentially invalid responses, including potentially mischievous responses, between LGBTQ and heterosexual youth responses. So why I like this approach is, what I said here is we need to determine what the items are that we would screen on, and then also what the response option is that is funny or mischievous or something. But it could be the case that if somebody is filling out the survey, they start out truthful, but then they may become mischievous as the survey goes on. When they say like, well, this is ridiculous. Why is somebody asking me these items? I'm just gonna mess around with the survey. Or they might become distracted, or they might say, this is a very long survey. I was going to provide truthful responses, but given the length of it, now I'm just going to skip things. I'm only going to fill in certain things, or I'm just going to have fun with it, right? So there can be elements to the survey that lead somebody to change their responses in the process of completing the survey too. So what's nice about this approach is without having to pre-specify the response options, we can also tap into maybe there's some inattention or satisficing, or there's maybe some straight line that's going on. Maybe there's a combination of all these different approaches that's happening. But the main point is we don't expect these patterns of mischievousness or inattention or satisficing or whatever to differ between truthful kids who are saying that they're LGBTQ and those who are saying that they are heterosexual. All these things on these items that shouldn't differ between these kids. Similarly, we shouldn't see different patterns. So the idea here is if we do see differences, we can reweight those differences, and in the reweighting process, make it so that the responses on these screener items are virtually identical after the reweighting. And once we have a set of kids who are equal in terms of what we are perceiving as driven by their mischievousness and attention satisficing, et cetera, things that are undesirable as far as survey responding goes, then their disparities and the outcomes that we do care about should also be similarly purged, provided that we have a valid screener and the process is valid. Then they should be purged or at least greatly mitigated in terms of these undesirable qualities. Okay, so the research questions are, what are the LGBTQ heterosexual youth relative risks for a wide range of outcomes? And are the reported relative risks robust to adjustments for potentially invalid responses? I showed you at the beginning what those relative risks were, but then we're going to see if they're robust to adjustments for mischievous responders. We then want to look across the items and then see if you look across all the items, are there characteristics of the outcomes themselves such that, for instance, low incidence outcomes might be less robust to adjustments. So for instance, a lot of kids report that they have smoked marijuana, but very few kids say that they have used heroin or cocaine. So do we see that the heroin and cocaine estimates are less robust to adjusting for mischievous and invalid responses than is the marijuana outcome? So we'll look into that. And then we want to see if the validity checking process itself is robust to researcher choices regarding how to identify potentially invalid responses. What I mean here is, I've said a few times that what matters is the process that a researcher goes through to say, these items should not differ between the groups that I want to compare. And because they should not differ, if we do see differences on these items, then that should be an indication that there is something amiss in the validity of the data between the two groups that I want to compare. Now, I might say, well, I've looked over the literature and I don't see differences between LGBTQ kids and non-LGBTQ kids in terms of carrot eating, salad eating, whatever, right? And so they should be valid items. Similarly, I don't see anything, they shouldn't differ in terms of asthma. But then somebody might say, well, you know, there is this study where adult lesbians were at higher risk of reporting asthma than adult non-lesbians. So maybe that asthma item isn't such a good item, and maybe that should be removed from the screener. So this is what I mean here with question 3. We want to see if you adjust the items that you will allow that human component of the process. Does the human allow the algorithm to include that asthma item or not, right? And how does then that result in differences in the outcomes that we do care about? Because what you would see ideally is that the process itself is relatively robust. But if the process itself is not robust, then it suggests that the human component is really important, and subtle differences in the human's choices are resulting in differences in the disparities that you get, which would not create a lot of, I think, trust or faith in this process itself. So this is important to check, and it's a more methodological point. Number 4, how does the new method compare with data removal, boosted regression? So what a lot of people have done really is they have flagged, if an item seems like it's mischievous or invalid, then we just extract it from the data set and we don't use it, right? We use the data that we think is valid. Well, in this process, anytime we've removed data, we don't really know if, you don't know if it is a valid data point or not, right? So you need to determine what is your threshold for whether or not something should be valid or not, and whether or not it should be removed or included in your estimates. So that's kind of what the data removal process does. And in this case, what we're going to do is we're going to use a reweighting approach where we assign lower weights to the outcomes, to assign lower weights to the individuals whose responses on the screener are most dissimilar and unusual. And we assign higher weights to the individuals who have more commonplace kinds of responses to the screener items, because we think that their data are more valid. And so we want to know, how does that compare with a data removal approach? We haven't done this yet. This is the one thing that I won't show you because I don't have that. And then the last thing, what we have done is we have coded all the outcomes dichotomously. So you saw everything was in relative risk ratios. So did you use heroin at all, or did you not use heroin? You could code things continuously because things are reported. Like, did you use heroin once in your life? Did you use it 2 to 3 times? Did you use it 40 or more times? And what we would expect is the mischievous responders should have more influence on the continuously coded outcomes, because they are more likely to select the extreme responses. However, what we've seen in past research is even a dichotomous coding usually captures a lot of what's going on. But the continuous does end up tapping into a bit more. And we want to explore this again with these new data. Okay, so the process for identifying what we're going to use in the screener, again, perhaps it's counterintuitive, but we want to use items that are theoretically unrelated to LGBTQ status. And we want to use them to predict whether or not somebody says that they are LGBTQ on a survey. So the items that we've identified are carrot eating, salad eating, fruit eating, potato eating, height, asthma, dentist visits, and then we include the survey weight too, which we don't think should differ. And then we adjust, as I said, we want to see, like, is the process itself robust to inclusion or exclusion of particular items in the screener. So we have 4 different kinds of combinations where we remove just asthma, remove just dentist visits, remove both of them, remove the survey weights, and we see how are things changing in the outcomes as the algorithm is allowed to consider different things or not. As you constrain the algorithm in ways or you allow it more flexibility, do we see it's identifying different kinds of kids, reweighting them differently, and therefore changing the outcomes. And then similarly, you might think, well, what if somebody, like, I know that there are differences in all the research between LGBTQ kids and non-LGBTQ kids in terms of bullying. And I know that heroin use still tends to persist despite changing a lot when you screen out kids. So I don't really think these would be very good items, because we would be including in the screener something that is very robust to whether or not we screen out kids, and something that changes considerably but still has some sort of differences. So these would kind of be, like, I think, conceptually bad items to include in the screener. But what if somebody were to do that? So again, this is kind of a methodological point, like how bad, if somebody include a really bad screener item, does it really change the estimates? Or is the information that we're gleaning from these other items enough that it's not going to affect things that much there? The big picture process is we start out identifying those items that shouldn't differ between the groups. We then predict membership in those groups from those things that shouldn't differ. And as I said, the logic there, although it's counterintuitive, is that the differences that we do see as a result of this should be driven by these unusual response patterns, not by true differences between the groups. We then create the weights that would equalize the likelihood of invalid responding between those groups. And we would estimate adjusted disparities using those weights. Well, we then want to compare how the adjusted estimates are to the unadjusted estimates. So we need to also have the kind of those base rates that I started out showing you at the very beginning of the talk. And this step number 5 is really what people would do if they weren't engaging in this kind of validity checking process. We then need to compare how different are the estimates from the adjusted and unadjusted. That's what we do in step 6. And because methodologically we're concerned about how robust is this entire process, we want to then go through and repeat this entire process over and over again, each time augmenting the items that are allowed to be considered in the screener. So what are we doing when I say we're reweighting? If we use the screener for the main screener, the original one, what I'm showing you here is the predicted probability to report being heterosexual based upon the screener items that comes out of the machine learning algorithm, the boosted regression process. So we have the heterosexual reported youth, and based on their responses, they are likely to, they have a high probability of reporting that they're heterosexual. And we also see the LGBTQ reported males with their probability of reporting that they're heterosexual based on their responses to the screener items are. We see that it's separated a little bit, but it's not separated a ton, which is kind of what you would expect, because you don't expect these screener items that shouldn't differ between the groups to really do a great job separating the probability distributions of these two groups. If you saw something like that, I think you should be concerned that something else is going on and you're probably screening on something that you shouldn't be screening on. But we do see a bit of separation. And so what we do in the reweighting process is, this is now what the distributions look like after the validity reweighting. And so what we see is there's more downweighting going on here for these kids who report that they're LGBTQ, and they actually have a pretty high probability based upon their responses to the survey items, on the screener items, to be identified as LGBTQ because their responses are so different from the bulk of the heterosexual respondents on those screener items. And then increasingly, their downweighting occurs less and less. And then there's some upweighting that occurs, or assigning of higher weights to kids whose responses look more like those of the heterosexual youth. But so just to give a little bit of context for who these kids look like, the kid who is LGBTQ, or the kid who has the lowest likelihood, who happens to also be LGBTQ, they're saying that in the past week, they have eaten carrots 4 or more times a day, every day. They've eaten salad 4 or more times a day, every day. They've never eaten fruit. They've eaten potatoes 4 or more times a day, every day. They have asthma. They've never been to the dentist. And their height is missing. Now, the height is missing is actually pretty informative, because the CDC recodes values of height and weight that they deem biologically implausible. They recode them to missing. So missing is informative here, and doesn't necessarily mean that they just skip the item, but rather that their response may have been so extreme that the CDC is like, this is impossible. So the kid who gives this gets a much lower weight, and their contribution gets downweighted considerably in the validity reweighting process. We have some kids here who are giving some unusual responses, like the height is missing. Similarly, they say they never eat fruit, which is unusual. They're not sure if they have asthma, but they do have other responses that look kind of normal, right? Where that is pretty typical, I should say, which is that they have been to the dentist. They're eating salads, but they're not eating salads with extreme frequency. So this is kind of a bit of a murky, maybe it's mischievous, maybe it's not, which is why or maybe it's invalid, maybe it's not, which is why it doesn't have as low of a weight here, and is going to get downweighted, but not downweighted as much. And then we have some very commonplace kinds of responses here, where, well, they didn't eat carrots this week. They ate salads a little bit. They ate fruit at least once a day, potatoes a little bit, an average height. They don't have asthma. They've been to the dentist. So a very commonplace set of responses, which doesn't raise any red flags for, this seems like a mischievous or invalid responder who's taking things, who's not taking things seriously. So these are the observations that tend to get more weight. This is what I showed you before, so I won't stick with this, but you saw that there were these disparities between the LGBTQ and heterosexual youth in terms of all these different outcomes. This is what it was that you just saw for the males, and this in the unadjusted, and this is when we adjust. And then this is the change in the relative risk from the unadjusted to the adjusted model. And so what we see is that there's a 61% change in the relative risk for the of LGBTQ and heterosexual youth in terms of their for intravenous drug use, where it was statistically significant. And we said that LGBTQ youth were 4 times as likely to use intravenous drugs in the unadjusted model, but that diminished. It's no longer statistically significant, and it diminished considerably. The change is statistically significant. Everything here is Benjamini-Hochberg corrected, because we're looking at so many different outcomes. And what you can see is there are bigger changes for these kinds of drug use outcomes than there are for things over here that really aren't changing much at all, like being bullied online, or being bullied at school, or feeling sad or hopeless, or considering suicide. So these disparities are staying relatively constant from the unadjusted to the adjusted model, and we see that they're are not statistically significant changes, and actually really there's pretty negligible changes. So we would say after the validity uh, reweighting, there are not changes in terms of whether or not kids who are LGBTQ are reporting higher rates of being bullied at school, but there are considerable changes in terms of their extreme drug use behaviors. For females, there's a similar pattern, but it's never statistically significant. I realize I'm like really late on time, so I'm just trying to go through things quickly now, but because I want to leave some time for questions. And Fred, please feel free to jump in and stop me at any point. Just jump in. So what predicts the variation? Oh, yeah, you were going to say something, Fred?
Oh, just that, that's fine, but we have about 2 minutes left, so
Oh, okay. Sorry, I will jump to the main conclusions. So do we think the item response extremity predicts the differences? Yes. So over here, what we see are these are the low frequency outcomes. So do you ever inject illegal drugs? Do you take steroids without a prescription? Here are more highly endorsed outcomes, such as using marijuana, being bullied at school. These disparities, this is the change in the disparity, these disparities tend to be more robust. The more extreme the outcome, the more sensitive it is to the validity screening process. These are the results of randomization tests to get a sense of how much this should be changing, and it's highly significant, both for males and also for females, so it's somewhat tempered among females. The patterns are robust to screener alterations. There are some differences that we would expect. I won't go through that. The dichotomously versus continuously coding, that doesn't seem to matter all that much, but as I alluded to before, continuously does result in slightly larger changes. These graphics are going to take too long to explain. The implications, don't trust teenagers. That's my little joke. It's just a question. Of course, we should trust them, and the vast majority of them are likely being honest, but there's a sliver of them that is leading to researchers publishing findings where they have what they're marking as highly statistically significant differences that may not actually be valid and robust. So I would implore researchers to use sensitivity checks where they would assess the validity of their data. I think this audience is likely already going to be doing that. We really need robust research for policymaking, particularly for LGBTQ youth, because we don't have much data on this particular population, particularly among adolescents. But it's not helpful if these policy recommendations are based on likely faulty data. The last thing to jump ahead here is just to say that these patterns do leave you with different impressions of the risk versus resilience of the groups. So the male LGBTQ youth in the adjusted outcomes, they, despite being bullied more often and being sad more often and thinking about suicide more often, we see that they're not really engaging in extreme drug use patterns at higher rates than heterosexual LGBTQ youth. So you end up with very different impressions of where those disparities are robust and what are the real, I don't want to say real, but you know what I mean, the things that are more robust between the groups. And if you have limited resources, which we know practitioners do have, then I think it's helpful to say, well, maybe it makes more sense to focus those limited resources to the areas where we see that after you engage in a validity weighting, robust pattern checking, that the things that you do see as robust are the things that perhaps we might want to focus more attention on. Thank you. And thank you for, yeah.
Yeah, thank you so much, Joe. So some attendees are leaving, but
Yeah.
but not everybody. By about three-quarters are still with us, which is a testimony to just how Fantastic your presentation was in this line of research. So I say let's you take a few minutes for questions, because we do
Thank you.
have, I think it appears to be 73 participants still online. If you you can either raise your hand or put a question into the chat, and I can read it to Joe. Any questions? So I have several, Joe, but let me just, okay. Oh, so just Lisa really enjoyed the talk but needs to leave. Okay. And
And
wish
I
you good luck.
completely understand. I'm not at all offended if people leave or whatever. Like, I thank you all for uh, listening to me for an hour go through this.
So Matthias asks, is there any evidence of this bias affecting reporting of race, ethnicity?
Yes. So I haven't been able to study that with the Youth Risk Behavior Survey, the YRBS, because of the way the CDC codes race and how certain groups kind of dominate others and replace things, and it doesn't follow the pattern that we would expect. So it's inconsistent with how we would need to check things. However, I did use the Dane County Youth Assessment to look at this. And what we saw is if we look at those, that was kind of like those 10 screener items initially, we saw that, so in Dane County, they were particularly concerned about, they wanted to have an item on, I believe it was Middle Eastern, Muslim American or something is how they labeled it, right? Which I realized that there's a conflation there of religion and ethnicity, but that was how the question was asked. And what you saw is compared to kids who reported that they were only white, the kids who reported that they were Muslim American were 700 times more likely to give all 10 low frequency responses. So, I mean, this is concerning because the reason the Dane County Youth Assessment included that particular option was because they were concerned about this subpopulation, this ethnic and religious minority group, and they wanted to learn more about them. But you could see these mischievous responders were creeping into, the kids who thought that it was funny to say that they were this ethnic and religious minority end up skewing the estimates of the risk for that particular group.
Hannah asked, do you typically see these same mischievous responders in the LGBTQ population as a whole, or just youth?
Yes, so I haven't looked in the entire I haven't looked among adults. I have focused my research on among kids, I guess. So I I think that there are some features of this of the survey design that might invite mischievous responders. So as adults, we tend to volunteer for surveys more often, or we get sent some invitation, we fill out the survey. So maybe we don't necessarily feel that the survey is forced on us in a way. Whereas the kids who are filling it out in school, this time is set aside, you fill out the survey. So in a way, it's kind of, you're almost inviting it through the process, the conditions that are created. We also do see, not with these data, but again, with the Dane County data, they had separated the data into, we had the middle schoolers and we had the high schoolers. And what you see is the middle schoolers were giving more mischievous responses than were the high schoolers. We couldn't compare 9th grade, 10th grade, 11th grade, and 12th grade because that was self-reported on the survey and it's self-susceptible to mischievous responder bias. So, but where we did have a clear separation, we saw that there were these aging kinds of effects where the middle schoolers were the worst, then the, but I think there would be different contexts for adults, right? So maybe if you're filling out a political survey and you're asked by a party that you don't belong to fill out the survey, maybe you're going to give more extreme responses, and maybe you yourself will become a mischievous responder given the context of the survey. So yeah. So I know there isn't a definitive answer there, but just to say that there, I think, is potential for things, and the context I think matters.
Doug asked, what did you use for training data in your machine learning models? Did you manually determine who were mischievous reporters for the training data?
No, it was so it was done with a split sample. So it was a k-folds cross-validation process. So nobody was yeah. So maybe part of that question is, did I say somebody is a mischievous responder and then allow the algorithm to learn from that? No. And this perhaps is counterintuitive, because what I've moved to in the more recent work is, before there was a separation where it was like, how many low frequency responses did you give? And that was what determined. So there was no link to identification of the group. More recently, I've moved to linking the identification of the group to the items, which you might think, well, wait a second, that seems weird, because now you're saying that the group itself is what's mischievous. Not really. So we think that as long as the items themselves are valid, which is the assumption that you would have to have if you didn't link it anyway, that if the items can distinguish these groups that they shouldn't be able to distinguish, then that information should be coming from an invalid source. So what the algorithm is doing is actually trying to identify differences between the LGBTQ and heterosexual kids. And I don't want to label the heterosexual kids as valid or anything, right? But they are kind of used as the benchmark here to say that we need to reweight the kids towards them. But similarly, there's going to be some heterosexual kids who are giving extreme responses and mischievous response patterns, and they will get downweighted as well. So there's just kind of a canceling out that happens among these groups.
And Tracy asks, has this been applied to LGBTQ barrier to healthcare access data yet?
I have not, and I don't know of, as we're kind of developing these methods, I assume that people haven't quite gotten into my head to, to figure out what the methods are and then apply them. So I'm going to assume that that has not been done. I think that there's a lot of potential to apply this kind of approach much more broadly. I just haven't done it yet. I'm interested in doing it. Feel free to contact me if you are interested in these topics, and we could think about it.
I have one question. Well,
Yeah.
I actually have several, but I'll just ask one. Do you have any idea who the jokesters are? I mean, because their not their carrot eating, but their demographic characteristics or anything else. And could the surveys screen them out prior to data collection, or in some other way mitigate their tendency to be mischievous?
Mm-hmm, mm-hmm. Yeah. Well, I don't know from the demographics that we have, because the problem is, they're filling out the demographics,
Right,
right?
right.
So in fact, what we learned from the ad health analysis was the kids who said that they were adopted when they weren't also tended to say that they were foreign born when they weren't. 99, this is a shocking number, and you're going to think that I'm misstating it. 99% of the kids who said that they were amputees were not. But of course, those who said that they were amputees also tended to say that they were adopted, say that they were foreign born. They also had, among that subset, they also had a lot of kids who were male identified in person, also presented as male, everything was as male, but on the survey that they filled out initially said that they were female. So, but we don't really worry about how this affects males and females, because that's a drop in the bucket when you're comparing males and females, because they're roughly equal in terms of their proportions in the population. But we do care about it when we start saying, well, what about Muslim Americans? What about trans kids? What about, right? So, and we are very concerned about intersectionality. But then I would love to study intersectionality and study it with these large data sets. And I think that's kind of where the field is going. But I think we need to think about how these kinds of survey biases, you now have like a double or triple, multiply minoritized group that you, similarly, those mischievous responders are going after them too.
Yeah, it's a thorny problem.
I'm not sure if I answered your question.
Yes, no, you did.
But,
I think what you told me is that it would be really hard to
no, yes,
identify
yes,
the jokesters in sort of, at least with respect to their demographics. I thought maybe the triangulation data, although I didn't
yes,
remember, yeah, might provide some information. But you also told us that these are administered in school and they're required of all
right.
students, and so to screen out some students seems impractical and a bad idea for many reasons as well. So
Yeah.
it seems like a tough one. But what no, but the methods you've developed are so clever and they're just brilliant. So um, I I think we probably are out of time. Though there's still 50 attendees online. There were a couple of questions about whether the recording will be posted anywhere. Yes, it should be on the site for the Michigan Program in Survey and Data Science. Um, and let's see. So yeah, that's that answer is also in the chat. Um, it sounds like, Joe, you'd be willing to entertain email inquiries
Yes,
that
certainly.
follow up on the presentation, and so I encourage um, the 45 diehard attendees who are still here or those who've left to reach out to Joe outside of this forum. I just want to thank you so much for sharing such fantastic research with us.
Thank you.
I think I didn't communicate that we only have 1 hour set aside for this, and I apologize for that. So you had to rush
No,
through.
I'm terrible with time. I'm
Okay,
sorry.
anyway,
It's my fault.
no, not our fault. Rana said, "Thank you. Super important work that has broader implications." I think that's a good note on which to wrap up. So thank you again. Wonderful talk, and look forward to seeing where this research goes. Um,
Great. Thank you. Thanks for inviting me, and thanks to everyone who's here and everyone who was on before. I really appreciate this, and I hope more people are interested in this topic and apply some of these methods. And I hope I can make them more user friendly so that people can apply them more easily. So
that sounds great.
great. Thank you all.
Thank you,
Okay.
and thanks everyone for attending.
Thanks.